Now, how do we calculate that AR value from these abundance values, right? So what we'll do, so we have a little formula that can be applied. So AR is the sum of relative isotopic mass times abundance. So isotopic mass is the mass of that particular isotope. So here the isotopic mass is 35, right? Isotopic mass is the mass of that particular isotope. So in that case, it's 35 times the abundance. Abundance here is 75%. We're going to work in percentages, right? Let's take it like this, working in percentages. So here you have that little symbol here, which means sum of everything. Okay, so this is one isotope. The second isotope is chlorine 37. So we'll add chlorine 37. This is the mass of the second isotope times the abundance of the second isotope, which is 25. Right? So these are the only two isotopes that I'm mentioning about chlorine here, divided by 100. Why 100? Because we are taking a sample of 100. So we're taking percentage. So percentage is a sample of 100. So when you calculate this, so you're going to do that in your calculator. When you're typing in your calculator, please use brackets. I'm going to explain to you how we're going to work this in your calculator. So when you're using your calculator, you're going to use brackets here. So if you want to do the calculation at one go, you'll have to include two brackets. So we'll have, press this one twice. So bracket, 35 times 75, bracket, plus 37 times 25, brackets, and then you're going to use this one again to close it, right? And then you type divide by 100, and then equal to sign. Right? So I would prefer that you do it in one line and you use the brackets correctly. And if you do that, you should get the answer to be 35.5. This is why in the periodic table you have decimal values as the relative atomic mass of elements. Let's try another example. So boron has two isotopes, right? You have so this is boron 10 and boron 11. The abundance is given and the relative isotopic mass is given. So this is the exact relative isotopic mass. This one here has been rounded up, right? Now calculate the relative atomic mass of boron. So relative atomic mass, AR, would be equal to the isotopic mass times the abundance. This is for one isotope, and you're going to add for the other isotopes as well. So 11.009, the relative isotopic mass of the other isotope, times its abundance. And then you divide by 100. Right? So the abundance is in percentage, so we divide by 100. And if you do this correctly on your calculator, you should get 10.8106964. I've given all the values here, but when you're asked to calculate, you're not expected to give me all the values. IB expects you to know how much decimal places or how much significant figures to report your values. Now, how you're going to do this? Here I have a calculation right? We're going to look at this. Here, if you look at the number of decimal places, this is 2dp, right? And this is 3dp, right? Same, this is 2dp and this is 3dp. I'm going to look at the minimum number of decimal places. So this is 2 decimal places. Minimum number of decimal places is 2. Therefore, I'm going to give my answer to the minimum number of decimal places. So I'm not going to report as this one. I'm not even going to quote it. I'll just say my answer is 10.81. AMU, atomic mass unit. Okay, this is the unit for AR. So please be careful when you're giving your final answer. It should be to the correct number of decimal places. Let's say I would have a calculation where I would need this AR value to do something else. Right? Let's say I'm calculating number of moles, which is mass divided by AR. Right? If I would be using this value in another calculation, then I'm going to use the calculator value. Right? So then you're going to save the answer on the calculator and then you're going to use it for your next calculation. Don't round up too early. Right? I'm going to keep on repeating this because this is very, very important in calculations. Now you're going to try the other examples, the other questions on your own, and then you check your answer.